So, hello children. We'll see some selected problems from exercise 13A. That is page, if you're following Selena textbook, pages 158 and 159. Okay. Based on this topic, Pythagoras Theorem. Okay. So, we have done some exercises in class. We're also going to see some more additional problems here from this chapter. So, yes, let me go on to the ninth sum. It says, two poles of height 6 meters and 11 meters stand vertically on a plain ground. If the distance between their feet is 12 meters, find the distance between their tips. Okay, so we have two poles. So first of all, let me draw those two poles. So like I told you, whenever we are doing problems based on geometry, this is Pythagoras theorem comes under triangles, which is a part of geometry, isn't it? It's always good to draw figures, rough sketches, so that we have an understanding of the problem. We are able to visualize the problem. So, okay, so now what I will do is I will draw the two poles. Yeah, two poles are given and they are of height 6 meters and 11 meters. So naturally the taller pole is 11 meters and the other one is 6 meters. So there are two poles, right? So let me just put in the data that is available. All right. So I have two poles measuring 11 meters and AB is 11 meters and the other pole CD measures 6 meters. Okay. So, and they are on a vertically plain ground. If the distance between their feet is 12 meters, this BD is given as 12 meters. Yes, this distance is given to me. Distance between the B represents the foot of the first pole, D represents the foot of the second pole. So distance between the feet is 12 meters. So that part of information also we have. Find the distance between the tips. What I'll do is I'll just change the color for you to understand. So we want the distance between the tips, this distance. See, I'm joining A and C. A represents the tip of the first pole. C represents the tip of the second pole. So the distance AC I want AC. So AB represents what? Pole 1. CD represents what? CD represents pole 2. Okay. And the BD, anyway, the data is given to us, the distance between the feet. So BD is 12 meters. That is also given to us. All right. I need to know what is AC, isn't it? So it's just that we have to apply the knowledge of Pythagoras theorem here. Now, before I start off, so what I need to do is, first of all, I need to draw a line parallel to ground. So BD represents ground, isn't it? I need to draw a line parallel to ground and passing through this point C. Okay, so this will be 90 degrees, isn't it? The pole and the ground are at 90 degrees. So you see this will be a right angle triangle here. So let me say drop, my construction will be drop CE. See, CE children, you have to drop CE perpendicular to AB. C is the tip of the shorter pole, isn't it? I'm dropping a perpendicular from C onto AB, and then I call it a CE. So now what do I observe here? See, you can see a right angle triangle here, isn't it? So I can see I'm just putting something yellow out there for you to understand this triangle. Yes, this triangle is right angled, isn't it? So I get, what do I get? I get triangle. I get triangle AEC is right angled, isn't it? 90 degrees. So in that triangle, I'll apply my Pythagoras theorem. So in this, I need to know, okay, before that, you know, in this triangle AEC, it's right angled at E, isn't it? You can see that. Let me just help you with that. See, this is point E, isn't it? This is E. This is a right angle triangle. At E, I have the right angle. EC, just follow my pointer. EC is how much? Same as BD, isn't it? So EC is equal to BD and it will be 12 meters. Let me put in that a piece of information as well. So this is 12 meters. So this is 12 meters. And you observe here. Now observe. So if you observe carefully, AB is 11. This entire thing is 11. So EB will be 6. See, this is 6, isn't it? CD is equal to EB is equal to 6. So this will be 6. Its entire thing is 11. From here to here, it is 6 meters. So from 11, if you take away 6, what am I left with here? Here. So this AE becomes, so this distance, yeah. Let me just put that clearly for you. So this AB represents 11 meters, isn't it? The entire height of the big pole. So this is 11 meters. And out of this, EB is 6 meters. So this portion is 11 minus 6, isn't it? So 11 minus 6 will be 5 meters. Yes. So AB is equal to this entire pole length. AB is 11, isn't it? EB is 6. From 11, if you take away 6, you're left with AE. AE will be AB minus EB, which is 11 minus 6, which is 5. So in triangle AEB, the yellow triangle which I marked in yellow, you have AE is equal to 5. Okay. That's one of the legs of the triangle AEC. EC is equal to 12. That's the other leg of the triangle. And I need AC. AC becomes the hypotenuse in the triangle marked in yellow, which is a right angle triangle. Simply apply your Pythagoras theorem. So what is AC square? It is equal to 5 square plus 12 square. 5 square is how much? It's 25, isn't it? 12 square is 144. 12 square is 144. What is 25 plus 144? It is 169. So AC square is 169. If AC square is 169, AC is 13 meters. So AC square is 169. AC is 13 meters. Yes, because square root of AC square is 169. So what is AC? Square root of 169. AC will be square root of 169, which is 13. See, otherwise also, if you know your triplets, 5, 12, 13 form a Pythagoras triplet. Yes, one of the base triplets. So the distance between the tip of the poles is 13 meters. This is the logic that you'll be using. I hope this explanation has been clear to you this far. So with this, now let's go to the next problem. That's question number 6 on page 159. In the triangle ABC given below, so I'll just draw the figure for you. They've given us a triangle ABC. Okay, so I'll just draw the sketch of this triangle. In the triangle ABC given below, so in the triangle ABC, AB is equal to 8 centimeters. I've just finished drawing the triangle. It's A, B, C. So I'm just drawing a rough sketch. Nothing is really drawn to scale. So ABC, this is O, and this is C. The triangle ABC given below, AB is equal to 8 centimeters. This is 8 centimeters. BC is equal to 6 centimeters. From here to here, it is 6 centimeters. Okay. And AC is 3. So this is 3. Here to here, it is 3. Calculate the length of OC. I want to know what is OC. So since I don't know what's OC, maybe I can say let OC equal to X. And likewise, I don't know what is OA as well. This is right angle, right? This is given as 90 degrees. It's given in the figure. So OA is equal to, what is OA equal to? OA is equal to, let's say, some Y. Just mark it as well here, Y. So everything is all marked here. So we don't need Y, we need what is X, because they've asked what is OC. So now remember, if I look at this figure, and if I ask you how many right angle triangles are there, you will tell me there are, at first sight it looks like there's one right angle triangle, that is triangle AOC. So let me just write that out for you. Triangle AOC, there is one small triangle you can see, isn't it? And remember, there's the mother triangle, the outermost triangle. So that is triangle AOB. even that is a right angle triangle. So technically, I'll be having two right angle triangles, and I can use the Pythagoras theorem for both the right angle triangles and get what I want. So let me start off with the smaller triangle, triangle AOC. Yeah, you can see that smaller triangle. Yeah, just put some blue shade out here. You can make out that this is the triangle I'm talking about. Yes, triangle AOC. It is right angled, isn't it? It is right angled. So when I'm talking about this triangle, let us apply the Pythagoras theorem. AO square, leg 1 square, plus CO square, that is leg 2 square, is equal to AC square. Obviously, AC is the hypotenuse. It is given to us, isn't it? AC length is given to us. So what's AO square? It is Y square. What's CO square? CO square is what? CO square is X square, and that is equal to AC square, which is AC square is 3 square. 3 square, isn't it? Okay, that's fine. Let me not skip the steps. I'll just put them out here. So Y square plus X square is 3 square, which is 9. Just have a relation between X and Y. Let's put that as equation 1. So now let us look at the outermost triangle, the big triangle, the mother triangle. In the big triangle, what do I have? I have that's triangle AOB, isn't it? There also, I can apply Pythagoras theorem. I can employ the Pythagoras theorem. So what are the legs there? AO is the leg 1, which is Y, and BO is the other leg, the outermost triangle. Just focus on the outermost triangle. It's BO. Okay, it's BO now. So if you look at BO, so what do you observe in BO? BO is what? BC plus CO. See, just observe the pointer. BO is BC plus CO. So BC is 6. CO is X. It is 6 plus X. So BO is 6 plus X. BO is 6 plus X. Okay, that's the other leg. And use your Pythagoras theorem. AO square plus BO square is what? AO square plus AO square plus, let me just write that down, plus BO square is equal to what? What is AO square plus BO square? That is 8 square, which is, okay. Maybe I'll just write that down. Wait, I'll not write, I'll put the constants later. AO square plus BO square is AB square, isn't it? The mother triangle, the big triangle. And now I'll just take this working here so that you can, I'll just put it in this page so that you cannot relate to this. The figure is here. So what is AO square? AO square is Y square. Okay. And BO square. What is BO? BO, I told you it is 6 plus X. So BO square is 6 plus X. This entire 6 plus X is being squared. So 6 plus X or X plus 6 square, yeah, is equal to what? Follow the arrow. It is equal to AB square. What is AB square now? 8 square. Maybe I can put that down as 64. That is 64. Yeah. Now you go back to your equation 1. Yeah, in equation 1, what do you see? Y square plus X square is 9. Or I can say Y square is 9 minus X square. See, finally, I don't need Y or Y square, isn't it? I want X because CO represents X, and that's exactly what I want. That's been asked in the question. So I can replace Y square as 9 minus X square. So I'll write it as 9 minus X square plus X plus 6 the whole square. Here you have to use your A plus B the whole square form. A square plus 6 square B square plus 2AB, 2 into 6 into X. 2AB is what? 12X, isn't it? A plus B the whole square is equal to, observe, 64. And the rest is, as you know it, you just need to cancel out the requisite terms. Minus X square plus X square will cancel out. 36 plus 9 is 45. So 45 plus 12X, okay, 45 plus 12X is equal to 64. And what is 12X? So you see it looked like a quadratic equation, but now it is reduced to a linear. 64 minus 45. What's 64 minus 45? That will be 19, isn't it? So 12x is equal to 19. Of course, you need to take care of the units also. It's centimeters. Implies x is 19 over 12. Yeah. And what's 19 over 12? It's 1, 7 upon 12 centimeters. Yeah. Mixed fraction form. That's it. So it's 12 upon 19 over 12 is 1 and 7 upon 12. This is your answer. 1, 7 upon 12 centimeters. That's my x. X is nothing but my length of OC. Okay. So I hope up till here the explanation has been clear to you. Okay, now with this, let's move on to the next one. It's exercise, question number 7, exercise 13A, over page 159. So we have the 7th one, children. So if you see here, in the data is given, and I told you always draw a rough sketch to denote or to get clarity from the word statement, word problem. So it's saying that, so if the accompanying figure is given, like in example in exercise 6, it was given, and it was given in 10. So it's good for us. Otherwise, we need to draw the figure. Yes, draw the figure. If the figure is drawn accurately, it's like half the problem solved. So in question number 7, let's say what it says. It says in triangle ABC. I'll draw the triangle ABC. They are saying that AB is equal to AC is equal to X. So indirectly, it is telling you that it's indirectly it is telling me that ABC is a right angle triangle. Okay, sorry, isosceles triangle. ABC is an isosceles triangle. It's given that AB is equal to. You might wonder where is Pythagoras theorem? Yeah, we'll see how we will be using Pythagoras theorem in this problem. So we have AB is equal to AC, which is equal to X. Okay, AB is equal to AC, which is equal to X. BC is 10 centimeters. BC is 10 centimeters. BC will be 10 centimeters. Okay, that's given to us. Okay, now with regard to an isosceles triangle, remember I told you BC is the odd side, isn't it? BC is the odd side, the unequal side. It's called as the base. And angle B and angle C become what? They are the base angles. Base angles are equal because in an isosceles triangles, angles opposite to equal sides are equal. Angle C is opposite to AB. Angle B is opposite to AC. Yeah, AB and AC are equal sides. The respective angles opposite to them will also be equal. Okay, that's also we have seen. Next one. The vertex angle is your A, isn't it? This. Or the vertex is A, we could say, the odd vertex, which contains the odd angle. Now, from the vertex, I'm going to drop a perpendicular. Technically, I would be calling as the altitude. I would call it as the altitude. See, I'm going to drop a perpendicular. You can see green dotted lines. So you can see I've dropped a perpendicular. So I'll call this point as D. You can see that, isn't it? AD. So what happens? AD is perpendicular to BC. AD is perpendicular to BC. So AD is perpendicular to BC. Now, when I was talking about the properties of isosceles triangles, I told you in an isosceles triangle, okay, from the vertex, if I drop an altitude, it's my altitude, right? AD is perpendicular to BC, so AD is called as the altitude. So AD is perpendicular to BC, and AD is not only the altitude in this case, it also acts like a median. So it is playing the role of both a median and an altitude in this case. Why is AD an altitude? Because I've drawn it in that way. I've said that AD is perpendicular to BC, so it's altitude. And remember, because it's an isosceles triangle, from the vertex, if I drop, opposite of the vertex is my base, right? So from the vertex, if I drop an altitude onto the base, that is BC, that altitude will be perpendicular to, the altitude will also act like a median. That particular altitude acts like a median. Okay, so AD is perpendicular to BC, and AD is also bisecting BC. The mathematical word that I would be looking for here is AD bisects BC, children. It's also bisecting BC. You can see that here. Okay, so you can see. So BC. Now, I'm not saying that I would require all of this here, but just see what happens now. So AD bisects BC. So now, do I know what is AD? I don't know, isn't it? I'll find that out. But I do know some other information that's given to me. It's saying that the area of the triangle is 60 centimeters squared. Area is 60 centimeters squared. Find x. I need to find out x, this x, right? This AB is equal to AC. So what is x ultimately? So I'll be using the properties of Pythagoras isosceles triangle also here. Okay. So let me write that down. See, area, now let me not be specific to an isosceles triangle. For a general triangle, what is area? Half into base into height. Here base is BC. Height is from the opposite vertex to the base, whatever, if perpendicular length distance is there, that becomes my height or altitude. In this case, it is AD, isn't it? My height or altitude. From the opposite vertex, if I'm going to drop a perpendicular onto the base, that becomes my altitude or technically the height. So half of base into height is the area, is equal to 60. Okay. So what is BC now? BC will be 10, isn't it? BC is 10. AD, I don't know. I'm going to find out now. It's going to be found out now. So now I'll just 2 into 5, 10. 5 AD is 60, or AD is 60 upon 5, isn't it? So AD will be 60 upon 5, which is 12. So AD will be 60 upon 5, which is 12 centimeters. Okay. Now also, I told you that AD bisects BC, isn't it? That means BD, if BC is 10, D we also, now D is like the midpoint because AD acts like a median also. So BD is equal to, so this AD is also acting like my median. This D becomes the midpoint. So BD is equal to DC and it's half of 10 each, which is 5, isn't it? So if I'm going to like kind of draw it a little more pronounced, if I just focus on this triangle, see here, see this is BD and this is AD, isn't it? See, I just focus on one. I get two congruent triangles actually, isn't it? Because it's an isosceles triangle. You see here. So I have triangle ABD. So now I know what is AD. What is AD now? It is 12. I've already got it, isn't it? I've computed the value of AD, which is 12 centimeters. Yes. And what is BD? BD is 5 centimeters. So by the Pythagorean triplets, 5, if this is 5 and 12, AB hypotenuse should be 13. Okay. So, but I will write down those steps. Okay. I'm going to write that down. So I'm going to take it here on another page. You can see I have, you just go back and see. It's A, B, D, isn't it? It's A, B, and D. So I have 5 here, and I have 12 here. Yeah, and this is my X. Yes, the unknown. So that would be what? Pi square, leg 1 square by plus leg 2 square is x square by Pythagoras theorem, isn't it? It's simple. So 25 square, 5 square is 25 plus 12 square is 144 is equal to, what is that equal to? X square, isn't it? 125 and 144 is 169. 169 is x square. So x square is 169. I'm just writing it the other way around because we are so used to this convention, isn't it? So that would be x is equal to square root of 169, which is 13 centimeters. Don't forget the units. And of course, remember, what we need to remember is we got the value of x as 13 centimeters. Even if I use my base triplet, 5, 12, 13, I know it, isn't it? 5, 12, 13, I should be getting this same value also. So by Pythagoras theorem, you can always mention by Pythagoras theorem. So when I'm writing the steps of making use of the property of the theorem, I need to mention it by Pythagoras theorem. So this is it. 5 squared is 25, 144, and so on. So we have used the properties of Pythagoras isosceles triangle along with Pythagoras theorem here. Yes, very most importantly, remember in an isosceles triangle, we have a triangle ABC. So if I say triangle ABC is isosceles, I need to mention two of the sides which are equal. In an isosceles triangle, two sides are equal. AB will be equal to AC. So the angles opposite will be equal. These are called base angles, isn't it? Angle B and angle C are the base angles. The odd side is the base. See, it's a leftover side. So BC is the base. The odd vertex, the leftover vertex is the leftover angle becomes the vertex angle, we can say. Yeah, A in this case. So this will be vertex angle, and BC is the base. So angle B and angle C becomes the base angles, and base angles are equal. Yes, and from the vertex, if I'm going to drop altitude, that is, which is drop a perpendicular onto the base, it will also behave like a median. Yeah, so AD is acting like a perpendicular to BC, that is, it is an altitude. AD is also bisecting BC. D is the midpoint of BC technically. So AD acts like a median and an altitude. That is why we can use the Pythagoras theorem, and we can also make use of the isosceles triangle properties out here. Okay, so I hope the explanation has been clear to you this far.